You pour yourself a glass of water. Would you know if it contains too much chlorine or if it's too hard because of excess calcium and magnesium? Although we can't tell just by looking at it, scientists can determine this by using volumetric analysis. Today, our group will explain how this technique is applied in water treatment to ensure clean and safe drinking water.
Good day everyone. Firstly, I will introduce the topic of this presentation, which is volumetric analysis. Volumetric analysis is a quantitative analytical technique used to determine the concentration of an unknown solution. This method involves measuring the volume of a standard solution, also known as a titrant, that is required to react completely with the analyte. In most cases, volumetric analysis is carried out through a process called titration, where the titrant is gradually added until the reaction reaches completion. By knowing the volume of titrant used, the concentration of the unknown solution can be calculated accurately. Volumetric analysis works based on a chemical reaction between two solutions, which are the titrant and the analyte. During the process, the titrant is added until the reaction reaches the equivalence point, where the amount of titrant is exactly enough to react with the analyte. From the volume of titrant used, the concentration of the unknown solution can then be determined through calculation. Besides that, volumetric analysis is important because it provides accurate and precise results. It is also a simple, reliable, and cost-effective method, which makes it widely used in analytical chemistry, especially for quality control and chemical analysis. Volumetric analysis plays an important role in water treatment because it helps ensure that water is safe for drinking and domestic purposes. One of its applications is determining important water quality parameters such as chlorine concentration, water hardness, and alkalinity. These measurements help monitor the condition of water and ensure that it meets required safety standards. Furthermore, by accurately controlling these parameters, water treatment facilities can protect public health and provide clean water for communities. Therefore, volumetric analysis is an essential technique in maintaining water quality and ensuring safe water supply.
Volumetric analysis is based on the principle of stoichiometry, which means chemical reactions occurred in fixed ratios. By carefully measuring the volume of solution of known concentration, called the titrant, we can determine the concentration of an unknown solution, known as the analyte. The process continues until the equivalence point is reached, which is the exact moment when the reaction is complete. To help us identify this point, we can use an indicator that changes color at the end point, signaling that the titration is finished. This theory makes volumetric analysis one of the most reliable methods in analytical chemistry. Now, let's look at how volumetric analysis is carried out in water treatment. The methodology is straightforward. First, a water sample is collected. Next, an indicator such as areochrome black T is added. Then, the titrant such as EDTA is delivered drop by drop from a burette into the sample until the color changes, indicating the end point of the titration. Finally, the concentration of the ions is calculated using the titration formula. This simple yet precise procedure makes volumetric analysis an essential technique for monitoring water quality.
I will explain a real-world application of volumetric analysis in water treatment. One common application is determining water hardness using EDTA titration. EDTA is a chemical that strongly binds to metal ions, especially calcium ions and magnesium ions. Hot water contains calcium and magnesium ions. If these ions are present in high concentrations, they can cause scale buildup in pipes and reduce the effectiveness of soap and detergents. During the analysis, a measured volume of water is titrated with a standard EDTA solutions. Because EDTA reacts with calcium and magnesium ions in a 1-to-1 ratio, the volume of EDTA used allows us to calculate the concentration of example. We analyzed 50.0 ml water sample using 0.01 molar EDTA. The endpoint was reached after 12.5 ml of EDTA was added. Using the equation C1V1 equals to C2V2, the concentration of hardness ions was calculated to be 0.0025 molar. Based on the result, the water is within the acceptable range and does not require additional softening. This shows how volumetric analysis provides accurate information that helps water treatment plants maintain safe, high-quality water for consumption.
To conclude, volumetric analysis is a fundamental technique in analytic chemistry because it provides accurate and reliable measurements of substances in solution. Throughout this presentation, we have seen how titration is used in water treatment to monitor chlorine concentration and water hardness, ensuring that drinking water meets safety and quality standard. The importance of volumetric analysis extends beyond the laboratory. By providing accurate chemical measurements, it helps water treatment plants maintain safe water quality, prevent health risks caused by contaminated water, and support compliance with environmental regulation. Ultimately, analytic chemistry contributes directly to healthier communities. The example of EDTA titration clearly shows that volumetric analysis is more than just an experiment. It provides the reliable data needed to make important decisions in water treatment, such as controlling water hardness and maintaining safe drinking water. This demonstrates how analytic chemistry safeguards our everyday life by protecting communities, industry, and the environment. This diagram shows the water treatment process from raw water to safe drinking water. Throughout these stages, volumetric analysis is used to monitor water quality by measuring important parameters such as chlorine levels and water hardness. This ensures the water is safe before it reaches our home. Overall, volumetric analysis ensures water quality through accurate chemical measurements, demonstrating how analytic chemistry safeguards our daily life. Thank you for your attention.